All right, what we got going on here? There's a manufacturer that determined how many faulty machines they have after they produce 1,000. So it's roughly one faulty machine every 1,000. Okay, so I'm going to stop right there. If you guys were trying to get a faulty machine, what's the probability that you would get a faulty machine? It'd be 1 out of 1,000, right? So the probability to get a faulty machine would be 1 out of 1,000. And you could divide those two to get the decimal, then multiply it by 100 to get the percent. But that's the percent chance, or that's the chance that you would get, the probability that you would get a faulty device. Okay, so what would the probability be that you would get at least one or more faulty units if you were getting 2,000 units? I want you to think of it like this. You're a company and you ordered all these units and they're coming one at a time in the mail. Every time you open a box, what's the probability of that one being faulty? Right? Okay, and then you get 200 units. That's a lot of probabilities. That's 200 probabilities.
Wow.
Now, if you guys are looking at all these different probabilities and you want to find out your final probability of getting what you want, you're going to have to take all those probabilities and multiply them together. That's intense. That's big. In fact, that makes this problem suck really bad. You know why? Because this represents 1. Now, if I want to find the probability that I would get exactly 1 faulty unit, I would need to take that probability and then multiply it times the probability of getting not a faulty unit. Now, that would be the probability of not getting a faulty unit. 999 over 1,000, right? Because that's how many I would want. Like you do want over total possible. That's 2. This would be 3. And this would be 4. How many times do I have to do this? 200 times. Now that stinks. Okay. So one trick that we can do in math is, instead of thinking about this event happening, and the event is we're gonna say that this event is I'm gonna name this event A. The event is getting at least one faulty. Whoa. So that's what I want to know. I want to know the probability of getting at least one. So I'm getting the probability of this event A, and that event is getting at least one faulty unit. At least one. Whoa, at least one? Yes, at least one. You know what that means? I also have to find the probability of getting 2. And then I have to find the probability of getting 3, exactly 3, and then 4, then 5, then 6, and 7, all the way up to 200. Okay, this sounds very, very obnoxious, right? So we got to think about this a different way. Let's attack it from behind. Okay, we went to the front door and we're like, nah, Doug. And then now we're walking around the back door, and I'm going to show you guys what is a backdoor approach to finding the probability of this event happening. This is what you do. You name the exact opposite event. Okay, what's the opposite of getting at least one faulty? Getting none. No faulty. 0. No faulty. Okay? That's actually sounding pretty easy, right? Okay, so can we find the probability of getting no faulty? See, here, check this out. If we do that, we can take that that probability of getting no faulty, subtract it from 1. Now, in percentage land, what does 1 represent? It represents 100%. Like, if you're thinking about probability, this is going to be a decimal between 0 and 1. And this 1 is represents 100%. So we're going to take 1 and we're going to subtract the probability, the opposite probability that we don't want. Okay, so in this case, we can do that. So what is the probability of getting no faulty? This one is a lot easier. You know why? Okay, now I have to do this 100 times or 200 times. I have to take 999 over 1,000, and I have to multiply it to itself 200 times. Is there a cool operation in mathematics that allows me to? Yeah. So we're going to raise this to the 200th power. Yes, you're going to need your calculator for this. Can you guys take 999 over 1,000, divide that, and then raise that number to 200, and tell me what you get? So we get 0.819. That's the probability in decimal form, not percent form. In decimal form, that's the probability of getting no faulty units. So like we can write this now. We can say the probability of getting no faulty units is 0.819. Now if we wanted to make it to a percent, you just have to multiply it by 100. So it's an 81% chance that you would get absolutely no faulty units. Okay, so now we come back to our actual problem. And what you can do here is you can take the 1 and you can subtract 0.819. And then this would equal P of A, the probability of getting at least one faulty unit. And that, what would that be? What is 1 minus that? 0.18. 181. Hey, that's not bad. That's a low probability. That's an 18% chance. Say we like 18. Like we like percents better. So you multiply a decimal by the 100. That's going to be your percent chance that you would get at least one. In the book, they actually switched the not A and the A, but this is just the probability of the complement. The complement is the opposite. Okay, the opposite of the event that you want, and that makes your life a lot easier.